So we're doing linear equations and relations. Yesterday we just talked about functions and relations. Now we're doing linear equations or linear functions. So we're being specific. Linear. Linear is an adjective here. What do you think this adjective means? What are the first four letters of linear? It's a line. So it's equations that make lines. Linear equations. All right. A linear equation has no operations other than addition, subtraction, and multiplication. Now, I want to change this around a little bit. Of a variable by a constant. I feel like I had that complete enough. Of a variable by a constant. All right, so here are some no-nos. Let's take 2x plus 6y squared equals negative 25. Okay? No exponents on your variables except one. Like this is 2x to the first power, right? No exponents except one on your variable. Y equals square root of x plus 2. No square roots. All right? Of variables. You can have square root of a number, but no square roots of the variable. Let's look at this one. X plus xy equals negative 5/8. We can multiply a constant by a variable, but we cannot multiply variables together. Can't multiply variables together. All right. Y equals 1 over x. All right? No variables in, let's just write D-E-N-O-M, in denominators. No variables in denominators. These are, they're perfectly fine equations. They're just not linear equations. Is that? I'm not saying they're not equations. I'm just saying they're not linear. All right. So you got your books open to page 71. Let's do that. Open your book to page 71. All right. Number 1. F of x equals x plus 12 over 5. Where do you want to put that one? In the linear column or the nonlinear column? Let's do that. Everybody. F of x equals x plus 12 over 5. Does everybody know y and f of x are interchangeable? Function notation, we can write with the y equals, or we can write f of x equals. Everybody's good with that? All right, so yeah, that's in the linear column. Number 2, g of x equals 7 minus x over x. Mark? Let's put that one in the nonlinear. Good. Why'd you decide to do that, Mark? X is in the denominator, right. Number 3, p of x equals 3x squared minus 4. Kellen? That is nonlinear. There's p of x. Why did you say that? Because there's an exponent on the variable, yes. And number 4, q of x equals negative 8x minus 21. It is linear. It is. Q of x equals negative 8x minus 21. Now your job is to look at numbers 16 through 24 and do what we just did. Put it in the proper columns. Brody, 16, linear or nonlinear?
Linear.
Correct. Jude, 17.
Nonlinear.
Nonlinear. Good. Louisa, 18. It is linear. That's a tricky one. There's no x in there. It's y equals 6 or h of x equals 6. It is horizontal. It's a horizontal line, so it is a line. It's linear. All right. Matt, 19.
Nonlinear.
That is nonlinear. 20. Maria.
Nonlinear.
It is nonlinear. 21. Sonia. That is correct. 22. Mark. Right. 23. Anissa.
Nonlinear.
Yes. And 24. Grayson.
Linear.
That is linear. Any questions? Everybody was correct. All right, very good. Now, let's go to the next thing here, where we're talking about linear equations being in standard form. Standard form, ax plus by equals c, where a, b, and c are integers. Integers, do integers have a decimal or fraction part? They don't. So we have ways of making sure that won't happen. So let's try looking at that with 1, 2, and 3 right now. One of the requirements, the x and y terms are on the left side. All right? Sometimes we've got to move things around for this to be in standard form. So, you see what I'm doing here? I am subtracting 4y from both sides. That's 0. 0 minus 1 is negative 1. This is 2x minus 4y equals negative 1. Now, you see that? You see it on you? Oh, okay. Thank you. You don't see that. All right. So I subtracted 4y from both sides. Those canceled, or that's 0, and 0 minus 1 is negative 1. And these are not like terms, so I don't put them together. Right? This one, number 2. First thing I'm going to do is subtract 2/3 x from both sides. I'll write negative 2/3 x plus 3/4 y. This is 0. 0 plus 5 is 5. Okay. So I've got the x and y on the same side. Am I finished? No. What else needs to happen here? What do A, B, and C, what did we say A, B, and C need to be? Somehow we got to get these fractions into whole numbers or integers. Okay? Yes. Okay. What I want you to do when you have something like this, you got fractions in there, look for the least common denominator. What would that be here? You've got a 2/3, you got 3/4, thirds and fourths. What's the least common denominator? 12. Agreed? 12 is the least common denominator. Okay, so what I'd like to see you do is multiply the whole doggone equation by 12. Notice I put the whole equation in parentheses. Now, I'm going to expand that out just to show what we're doing here. 12 times negative 2/3 x plus 12 times 3/4 y equals 12 times 5. So you see 12 is by every single term. Now 12 times negative 2 is negative 24. So that's negative 24 over 3x. 12 times 3/4, that is 36 over 4y. And 12 times 5 is 60. And if I divide negative 24 by 3, what do I get? Okay. So we got negative 8x. What's 36 divided by 4? 9y equals 60. So we did it. This is what Michaela said we needed to do. Do you see the least common denominator? We'll get this so that you won't have any more fractions. All right? So that's what you do in this case. Now, number 3, what's got to happen here? I need the constant, which is 10. I have 6y minus 8x equals negative 10. And what else needs to happen here? All right. Now keep the negative with the 8. So negative 8x, very good. The 6y, that's positive 6y. And negative 10 here. All right, any questions on that? Let's take a look at number 4. Number 4 is the last one I kind of want to look at together. Now, this has a decimal in it. Any thoughts on how to, like we multiplied by the least common denominator with fractions, what do you think we could do with decimals? Multiplying is a thing. Yes. You have one decimal place here. If you multiply the whole equation by 10, I think that'll do the trick. What would you multiply if there were 2 decimal places? By 100? So the number of zeros will move the decimal, right? So I'm going to just show it this way. 10 times 0.4, what is that? 4. So we got 4x, 10 times 3 plus 30y, and 10 times 10, 100. Be careful, sometimes you'll remember to do these two and forget to do this one. Everything needs multiplied by 10. All right, that is in standard form. Let me have you work on 5 through 9 for a little while here. It's a method to use if it's in standard form. I'm going to write that down. Use when equation is in standard form. All right, so the first thing you do is find the x-intercept. And to do that, you set y equal to 0 and solve your equation. Okay? Second thing you do is find the y-intercept. Set x equal to 0 and solve for y. Plot both intercepts and draw a line through them. I call this thing an intercept table. You have an xy table, put the 0 in for x, calculate y, put the 0 in for y, calculate x. So I always kind of draw this first if I want to graph an equation in standard form. Any questions there? All right, well, let's go over to the next page. It is 2x plus 3y equals 12. And we want to graph this using the intercepts. All right? So I'm going to do those steps. We're going to do them in an intercept table. Put a 0 here for x, put a 0 for y. Now some people just use that cover-up method. I'm going to, as we start here first, have 2 times 0 plus 3y equals 12. 2 times 0 is 0, right? 0 plus 3y is just simply 3y equals 12. Some people will just cover up. See, you have 3y equals 12. I'm just showing it. Divide by 3, you got y equals 4. I'm going to put a 4 here when x is 0. Now when y is 0, I have 2x plus 3 times 0 equals 12. And that's 2x plus 0, which is 2x, equals 12. Divide by 2, and I got x equals 6. And then, see, I can just cover up on that one. When y is 0, cover up the 3y. 2x equals 12. I had 2x equals 12 here. All right. Plot each intercept. 0, 4. 1, 2, 3, 4 is right here. 6, 0. 1, 2, 3, 4, 5, 6. 0 is right here. And I get my handy dandy straight edge and just draw a line through them. All right. Any questions there?